So this will map to 5. Next is key. So is name a key of dictionary D?
False.
False, right? Name is a key of this nested dictionary. Key of D is 1. So this will map to false. Next, D of 1 of age. So what should this give?
12.
True.
12. First option.
1. Next is first of L plus last of init of L. First of all, tell me what is first of L?
Ma'am, 8.
8.
8.
What is init L? Which element should be removed?
First element.
Init.
8 should be removed.
Ma'am, last
Minus
element
6
should
should
be
be removed.
removed.
-6 should be.
And 8 minus 4, 10. 4 will be 9 colors.
First init means
And
what? Which element is removed? First or last?
last
Last
element
element.
to be removed
Last
and the
element.
first.
Last is removed.
uh,
Okay, so
Yes,
some people
ma'am.
are saying first. So rest means what? Rest means that first element is removed, rest of the list is printed. Init means last element is removed. So here first negative of 6 will be removed. Then you have to find the last of the remaining list. So last of these 4 elements is 4, right? So 4 will come here. So 8 plus 4 is 12.
12.
So again, this should point to the first one. Last number, this is E. Okay. So first, what is rest of L? Again, let's remove all of this. So this inner rest,
Rest of L is minus 4, 10, 4, and minus 6.
right? So this element is gone. Then again, rest of that. So the next first element is
Ma'am,
gone.
E का 2 होगा. E
Right.
should be matched with
Because first
10.
of this, so now this is my remaining list. First of this list is 10.
So, ma'am,
So
it
E
would
should be
be
mapped to 10. Yeah, anyone got other different answer? Please tell me. See, first you do the innermost one, right? Innermost function. That is, first you do the rest of L. That removes the first element, which is A. Then again, rest of whatever is now currently L. So again, the next first element minus 4 is removed. Next, you do first of the remaining list. So remaining list is 10, 4 minus 6. First of that is 10. So it is mapping to 10. Last, keys of D. What is keys of D?
Matched with 3.
1.
It should be a list of keys of dictionary D. That is,
ma'am,
this,
third option.
this maps to 3. So did we find any invalid expression?
No, ma'am.
No. No, ma'am.
Is everyone sure? You have agreed with everything I did, right? You have not raised any question. So according to us, which one is the answer? A should map to 5, B should map to 4, C should map to 1, D should map to 1, E should map to 2, and F should map to, again, 3.
3.
So 5, 4,
B
1,
option.
1, 2, 3.
That's option B.
So according to us, this is the answer. Let's check again. So B is the answer, right? Sometimes might make this mistake of seeing that there is another option, invalid expression. So some people might say that this could be an invalid expression. It is not, right? Because the arithmetic operation is being performed on the actual integers. It is not a list append or list operation. Correct. So all of these are valid ones. So option B is correct. Anyone has any difficulty in this question? Any doubt?
No, ma'am.
No, ma'am.
Okay. So next. One second. Okay, this is for 2 marks. Now, what will be the value of out list at the end of the given procedure? So you have one list, first of all, which contains 1 to 50, all integers. That list is called N. Next, you have A. A contains sum list N. So this sum list is a procedure, obviously. Whatever this, so what does this sum list procedure take as argument? This list N. Now, whatever this procedure returns will be stored in A. So at this point, when in line number 2, your control should shift to line 13. So first you execute this. So what is sum list doing? It takes a list, in this case N. It has one empty list called out list and another variable called new list in which you store the argument list. that is n in this case. Then you check while the length of new list is greater than 0. That means as long as the list is not empty, every iteration you will do what? You will append the first of new list to out list. Right. And then new list will be rest of new list. So when you do rest of rest, that means how many elements are removed?
First two.
First two
First two
elements.
elements are removed.
2 elements are removed. So in every iteration, first 2 elements are being removed. So think about it now. You have this list 1 to 50, right? So in first iteration, 1 will be there in out list, right? You
These
add
should
1.
be from 3 to
Then
50.
2 and 3 are removed. Okay. Then next iteration, which list should be there? Which element should be there? 4. 4 will be added. Then again 5, 6 are removed. Again 7 will be added. So like this, you will add every element that comes third, right? So the third element will be there and the next 2 again removed. Again the third element is there. So out list will contain elements like this, every third element. And then you return the out list once your new list is exhausted. Right, now once you return that, that is now stored in A. So in our case, new list will contain elements like 1, 4, 7, 10, 13, right? Like this. So now B contains what? In B, we are going to store rest of n, which is being passed as argument to some list. So currently this is our, so let's write the whole n. Okay. So how many elements should be there? So 1, 4, 7, 10, 13, 16, 19, 22. Just to understand better, I'm writing. You don't have to do all this during exam. 28, 31, 34, 37, 40, 43, 46, 49. These many elements will be there. Right? Now, what is the rest of this? Which 2 elements are removed?
Ma'am, it will start from 7.
See, this is the A list. Okay. But here we are doing rest on N. So
1
has
and 2 will
N
be
been
moved.
changed? N has not been changed. So here this is the original list only. A contains these elements, but this sum list procedure is taking N as argument. So it remains the same. 1 and 2 are removed. So this will start from 3 up to 50. That is being taken as argument. So again, the same sum list procedure will execute. So now B will be storing which element? Starting with 3, right? So
Yes, ma'am.
3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Anything else will be there?
No,
No,
ma'am.
ma'am.
Okay, so now we have A and B list. Now there is one more out list here, which is initialized as an empty list. Now for each Y in A and for each Z in B, we match the elements. If they match, then those elements will be, then the Y element will be added in out list. So first let's check, are there any matches between any elements in A and B list?
No, ma'am.
No, ma'am.
No matches are there, right? So out list will be what at the end of execution?
Empty.
Empty.
Could be an empty list. Okay, there are no such options. We must have made some mistake. Let's check again. So we had list 1 to 50. Okay, then we have A in which we are running some list of n, right? So here we have out list. In new list, we are storing n. As long as n is greater than 0, length of new list is greater than 0, out list will be appended with the first element in new list.
Odd numbers only.
Okay, so if I go according to the procedure, if I have this list 1 to 50, then in sum list, First, it will start with 1, right? 1 will be appended to out list. And in new list, we will be storing the next 2 elements are removed. So now new list is what?
3.
3. It is going to start from 3. First 2 elements removed. Again, 3 will be appended. Next, again 2 elements are removed. So, which ones are removed now?
We having in the
Okay,
end
see,
all the
what we
odd
have
numbers.
done,
Oh,
see, what we have
Have
done
we,
is,
when we took 1, we started from 2 when we were
yeah,
removing the first 2 elements.
that's the
It'd be
mistake
like
we have
1,
made.
3, 5. So
Because 1 itself will be removed, right?
so the rest of formula. First rest
See,
of
will be
first
3,
in
6.
out list, in the first, this number 2 call, right? Number 2 line when we call sum list. Then first element in out list is 1. Okay. In A next, in new list next, from where we will start, we will remove the first 2 elements.
So 1
So
and 2
what
will
is
be
starting?
removed.
1 and 2 is removed. Next element will be added is 3. Right.
3.
Again, then 3 and 4 will be removed. We'll be adding 5. 5 and 6 will be removed. We'll be adding 7. So all odd elements will be added in this. Right. So when you come back and return that value to A list is list of all odd numbers from 1 to 50. So will 50 be included?
No,
No.
ma'am.
No. It will contain up to 49, right? Next, you have this line 3 call. So here you first start with number 3, right? Rest of n is first 2 elements are removed. So you're starting with 3. Now when you go to sum list, so out list 3 will be added. Next, which elements are removed? 3 and 4 are removed. Again, 5 will
ma'am.
be added. Right, again 5 and 6 are removed. 7 will be added. Are we doing correct? Anything is missing?
No, ma'am,
Ma'am,
that's
can you
fine.
come again?
In line 3, we are taking this sum list procedure and we are taking argument rest of n. So this is n, 1 to 50. Rest means first 2 elements are removed. 1 and 2 are removed. So now n is 3 to 50, this list. Now you do the same procedure on this list. So the starting element is 3. 3 will be added to out list. 2 elements are removed, 3 and 4. 5 will be added to rest list. Again, 5, 6 removed, 7 will be added. Like this, all the elements are added, right? So what is the difference between these lists A and B? Only
One
one
is-
element.
Only, ma'am, the first element 1 is present in A.
Only
and
this is present in A and not present in B, right? So now when we match the elements between A and B, what should this outlist contain? All the matching elements. That means all odd numbers starting from 3 up to 49.
49.
So which option is that? Option D.
Only.
So who has a doubt in this? Anyone needs me to explain this again?
Why do we have these two outlets? Because the same procedure we are doing up at the top part. Why are we
See, once
repeating
the
it in the
procedure
procedure?
is, once the procedure has been called in line 2, right? Again, it has been called in line 3. So both times you have to
Oh,
execute the
okay.
same procedure, right? And those lists are
Oh.
getting stored in A and B.
Mhm.
Next, you again initialize another out list, which is empty. And then you just compare all the elements in list A with list B. So wherever you find a match, you are going to add those elements. So since we have seen that list A and B are exactly equal, except list A has this one extra element. So definitely the intersection of these two lists will start from 3 up to 49. Is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now this is a good question. So two trains are called opposite trains if they stop at the same set of stations but in reverse order. That means I am in one train, let's say train T1, if it goes from station A to B to C to D, and T2 goes from D to C to B to A. then these two are opposite trains, right? Because they go through the exact same set of stations, but in opposite reverse order. So is opposite is a procedure which take N1 and N2, which are two trains. Please mute yourself if you don't have a question. Who is this? Okay. So N1 and N2 are two trains that we will take as our argument in this is opposite procedure. Now this procedure will return true if these two trains are opposite, that is they travel through the same set of stations in reverse order, or false if they are not opposite. So trains is a dictionary with train number as key mapped to the list of stations through which that train runs. Like in trains dictionary, one entry is like this 12281. This is the train number. The corresponding value is a list of stations through which this train runs. So it starts at Bhubaneswar, then Balasore, Adra, Varanasi, Kanpur, New Delhi. Right. So like this, there are multiple such trains and multiple such station lists. Now in this example, the train with train number 12281 starts from Bhubaneswar, reaches New Delhi via these stations in this exact order. So you have to choose the correct code fragment to complete the procedure. So what do we have to do? We have to make sure that this procedure returns true if two trains that we have taken as argument are exactly opposite, or false otherwise, right? So first, see, L1 is storing trains of N1. That means what is L1? It is the list of stations through which train N1 runs in the exact order, right? L2 is list of stations through which train N2 runs in that exact order. Now, if they are opposite trains, first what should be the point to note? That these two should run through exactly the same number of stations, correct?
Yes, ma'am.
So if
Yes,
the
ma'am.
length at first is different between these two lists, that means they are not running through same number of stations. So they cannot be opposing trains. So you can directly return false here. Right. Now, if their lengths are equal, then we again check. So now you will run a while loop, which we will run until list 1 becomes empty. And at every iteration, we are going to check is first of L equals, if first of L1 is equal to last of L2. That means in this example, like I said, so I will check this is equal to this or not. The first of T1 should be equal to last of T2. Again, next B should be equal to the second last element, right? So we will run this while loop until L1 list becomes empty, because they are both having same number of elements, right? So obviously they will both become empty at the same time. Since at every iteration we are doing what? For L1 we are doing rest of L1, and for L2 we are doing init of L2. Because we are already comparing first element and last element from L1 and L2. So we can remove those two before the next iteration, right? For better understanding, let's write it. So let's say I am doing the first while iteration. So L1 is what? ABCD. L2 is DCBA, right? L1 is non-empty. First of L1 is what? A. Last of L2 is B. These two are matching? Yes. So your while condition is satisfied. You come inside the loop. L1 is now changed to rest of L1. What is rest of L1?
BCD.
BCD. And what is init of L2?
DCB.
DCB.
DCB. So like this, you will continue until L1 becomes empty. So when L1 is empty, obviously L2 is also empty. Correct. If they have same number of stations. So once this is done, then there is some code here, which we have to find out what is the correct code. So now you see the option. First option is saying we will now check if L1 is empty, return true, else return false. Is this correct?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
if we have come out of the loop, here we have already done the comparison, right? So if it means that we have done all successful iterations of the while loop and then come out of it, so that's when will that happen? When L1 and L2 are both empty, right? Because we have compared all elements and all of them have matched. So if now I check that L1 is empty, that means these two are definitely opposing trains. So I will return true. If L1 still has some elements present in it, then obviously it is false, right? That means it did not find a match. See, if it was like this in A, B, C, D, here if this instead of D, if it had some K, then this K would not find a match with D, right? And at that point, the while condition will be violated, it will come out of the while loop. But L1 will still have one element present in it. That means not all elements matched. So we will return false in that case. So option A is correct. Option B, this is an MSQ. So if L1 is empty, return false, definitely not. So this is the wrong statement. This is wrong. Option C is saying if L2 is empty, then return false, else return true.
That is also wrong.
Ma'am, that
This
is
is
wrong.
also wrong. Because if L2 is also empty, it should return true only, right?
Yeah.
So option D is correct.
Yes, that's good.
So either L1 or L2, we can check any of them. If any of them are empty, we can definitely say that these are opposing trends. So A and D are answers. Any doubt here?
No.
No, ma'am.
No, ma'am.
The next one. Again, trains is a dictionary with train number as key mapped to list of station through which that train runs. Same thing as last one. At the end of execution of the code below, L stores the names of stations through which the maximum number of trains pass. Okay. So L is the names of stations through which maximum number of trains are passing. You have to choose the correct code fragment again. So stations is an empty dictionary initially. N is a variable assigned 0. L is empty list. For each X in keys of train, what are the keys of trains?
Train number.
Station
Train
number,
numbers.
train number.
Train number, right? See, this is the key. And value is the list of stations through which this train runs. So for trains dictionary, keys of trains will contain a list of train numbers. Now we are going through each of those train numbers, and in stations dictionary, we are running this update dictionary procedure. So let's say trains dictionary has some values like this, like 12281, 13429, 19952, something like this. This is the trains dictionary. So for first iteration, I'm picking this train. And I have to run this update dictionary procedure with the stations dictionary and this particular train number. So what does update dictionary do? This is the procedure. So it takes a dictionary and some value Z. Now for each A in trains of Z. So Z is a train number, trains dictionary for that train number, what is stored? The list of stations through which that train runs. So now we will go through each of those stations through which this train runs. And we'll check whether that station is already a key of this dictionary stations or not. If it is not a key, then we'll create a key and assign it the value 1. That means one train passes through this station. If it is already a key, then we'll just increment the value by +1. That means it is already a key. That means we have already gone through some train which has gone through this station. So now we have found
Ma'am?
another train which goes through this. Yes.
Ma'am, can you explain this procedure again? I could not understand it.
See, what is this update dictionary procedure taking as argument first? Stations dictionary and the train number, right?
Okay, ma'am.
Now, what is trains of Z? This Z is nothing but the train number. So 12281, for example. So what is trains of 12281? List of stations through which this 12281 train runs, correct?
Yes, ma'am.
So for each of those stations, we are checking whether that station, that is A, is already a key of this stations dictionary. If it is not, then we create a key value pair, right? So then we create an entry for that station and we assign it the value 1. That means this is the first train that we have found which goes through this station. Else, if it is already a key, that means we have already found other trains which have gone through this station. So we don't have to create it again. We just have to increment that. Now one more train we have found which goes through this station. So what
Okay,
is
ma'am.
this? Yeah. So what is this procedure actually doing for the stations dictionary? What is stations dictionary storing?
Number of stations.
So stations dictionary keys are what? Unique stations, right?
Number of trains going through the same set of stations.
I'm just asking, in stations dictionary, what is the key value pair? What does it signify?
Station names.
Keys are station names. For each station name, what is the corresponding value signifying?
The number of
Number
trains.
of
Trains
trains.
pass through that station.
Number of trains passing through that station. So that is your stations dictionary. Now next in line 6, for Y in keys of stations. So keys of stations is what? Unique station names. Now some code is there which you have to fill. So what is our goal? That L should store the names of stations through which maximum number of trains pass. So definitely we will just check the values of this stations dictionary for every unique station, and every time we find a higher value, we are going to store that station name. Correct. Now there can be more than one station through which the maximum number of trains pass. So in that case, how will we store those station names? In this list L. That's why it is a list, right? Because there can be more than one such stations through which maximum number of trains pass. So now this part, 7, 8, 9, these 3 lines are simply finding the maximum. So see the first option. For each Y in keys of stations. That means some unique station name. So you're checking if stations Y is equal to N. What is N? In the beginning, we have assigned N as 0. Right.
Ma'am, shouldn't it be greater than N?
Could be anything. Okay, I'm just checking the options. So first it is saying that if stations Y is equal to N, then you add that station name to list. Next you check if stations Y is greater than N, then list is updated. And N is now equal to stations of Y. So is this option correct?
Yes, ma'am.
Yes, it
It
is.
is correct. Right, it is the correct
Yes.
implementation of finding maximum. So basically N is storing what? At any point N is storing the maximum number of trains that passes through any station. Right. And every time you find a higher number of trains, then N is updated, list L is also updated. So if you find certain stations through which the same number of trains are passing, in that case, all their values will match with N. And in that case, you will just append those station names to L. Right. So this is the correct implementation of maximum. This is MSQ again. So option B, you check, is it correct?
No, ma'am, it's not MSQ.
Is it MSQ or MCQ?
No, ma'am, MCQ.
That's G1. Okay. Then should I explain the other options or will
Ma'am,
you?
your voice is not audible.
I'm not audible.
Ma'am, you are like barely audible, like you are whispering. That low the
Can-
volume is, I think.
Can others hear me?
Yes.
Very
Yes.
clearly.
Yes, ma'am.
Yes, ma'am. Your voice is very clear.
Maybe you can try rejoining. This happened with you last session also. Okay. Just try rejoining once. Okay. So should I go through the other options? Anyone wants? If you're not able to discern the wrong ones, okay, let me just quickly do this. So why is option B wrong? What is the wrong statement here? So when we find matching values with N, right, that means those stations should be appended. So
Yeah,
this
but there
part
is
of the
no
code,
append.
so these are basically interchanged. This should come here, this should come here. Right. Also, you should be checking this one. It is better if you check this condition first. Here, what is wrong? So here
Else,
N is being
else.
updated. Right. Is there any point in updating N if stations Y is already equal to N?
No, ma'am.
No. Again, this else part not required. I mean, this entire thing is not required. This line also. Here, stations Y, if it is greater than N, then we are appending to the list. We should not append, right? Because if we have found a greater value, then all the other stations should now be removed from the list. So it should be reinitialized to the current station name. So this one is also wrong. Only the first option is correct. This is clear for everyone?
Yes, ma'am.
Yes, ma'am.
Now this is a 5-mark question. So following pseudocode is executed on your shopping mills dataset. At the end of execution, count pairs should store the list of triples such that every triple has 2 items and the number of times both the items have been purchased together, right? So count pairs is what? It is a list. It should store triples. So each triple is of this format. Every triple has 2 items and the number of times both have been purchased together. For example, if milk and bread are the 2 items and they have been purchased together 3 times, so the triple would look like milk, bread, 3. Purchased together means what? Both items are in one list, in one shopping bill. Okay. So the procedure get pair X, X is the card, like one of the cards from shopping bills data set. The procedure get pair X returns the list of pairs of items purchased in card X. Okay. For example, if milk, bread, sugar are present in the card, this get pairs will give you all possible pairings: milk, bread, milk, sugar, bread, sugar. Okay. So we have to choose the correct code fragments to complete the pseudocode. First, let's understand. So count pairs is your list, which is the actual one we want. X pairs, pair list. Now, in the first while loop, you go through all of the cards in the shopping bills data set. You read the top card. And in X pairs, you are calling get pairs. So get pairs procedure again does what? It will give you all possible pairings of all the items in that list, right? So
Yes,
that
ma'am.
will be in this format, list of lists. So X pair is your list of lists. Now pair list, after that pair list is being updated with X pairs. So every time you find these all possible pairs for a card, so they are being again added to a separate list called pair list. So what is pair list?
Ma'am,
Pair list contains, yeah,
ma'am, will there be list of list, like
exactly.
there be 3 list
Yeah.
brackets, right?
Yeah.
Okay.
So this is pair list. Inside that, each element is a list of lists. So for example, let's say in card 1, elements present were milk, bread, sugar. So what are the possible combinations, pairings? These, right? So the first pair list element is milk, bread, milk, sugar, bread, sugar. This is one element of pair list, this entire list of lists. So like these, multiple list of lists will be there for as many cards as are there, right? Because for every card, we are finding all possible pairs of elements. Up to this, is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now see, line 9. While length of pair list is greater than 1. So as long as you have at least one element left in your pair list, as it becomes 0, or like if it's the last element present, obviously, if there is one element, then you won't do it, right? So as long as the length of pair list is greater than 1, rest list is introduced, which is an empty list. So remember, since all of these are inside the while loop, that means all these initializations will happen for every iteration of this while, right? So rest list is empty, first pair list is empty, triple is empty. All these are empty lists. Pair
Ma'am, I
count,
have a doubt.
yeah.
Ma'am, length of pair list greater than 1. So in this pair list, we have milk, bread, milk, sugar, and bread, sugar. So will the length be 3?
No, pair list. Pair list is a list of, that's why I explained it here. Pair list is a list of many such elements. This is one list of lists for one card. There are multiple cards. For all cards, we are adding it to pair list. See?
Ma'am, so for this pair list, the length will be 1.
No,
One
length is
item.
not going to be 1. I mean, for this example, I have taken
Yeah.
just one card. So as many cards as you take, that many list of lists will be generated.
Oh,
So that
okay.
many elements are in pair list.
Okay, ma'am.
Okay. So these 3 empty lists will be initialized for every iteration. Pair count will be assigned to 0. Item 1 will be assigned none. Item 2 will be assigned none. Now first pair. First pair is a variable in which we store first of pair list. What is first of pair list? The first list of lists, like this one. Okay. Item 1 is first of first pair. So what is first of first pair? In our example, what is first of first pair?
Milk.
Milk.
Carefully. What is the first pair? This entire list of
Milk
lists.
bread.
Milk and bread.
Milk and
Yes.
bread.
So first of first pair is the first element, which is milk and bread. Again, item 2 is last of first pair, which is bread and sugar. Right. Now for each pair in rest of pair list. So rest of pair list means every other element, every other list of lists for the every other card. What are we comparing? We are checking if first pair. So what is first of pair currently? For each pair in rest of pair list. So let me take another such list. So let's say we have some milk bread. We have also purchased a pen, so milk and pen, and another one is pen and bread. Okay, this is another element in pair list, second element. Okay, so for each pair in rest of pair list, so now rest of pair list starts from this element, right? The first element is removed. So what is first of pair? What is for each pair in rest of pair list? This entire thing is the pair, right? What is first of this?
Milk bread.
Again, milk
Milk.
bread.
bread.
So is milk bread is equal to item 1, which is also milk bread. So we have found a match. Or last of pair is equal to item 1. So we are checking that is the first pair or the last pair of the next pair list element equal to item 1. Item 1 is the first of first pair. So if any of them are equal, then we do something here, right? There is an OR statement. That means any of them can be equal. Else, if none of them are equal, in that case, rest list is a list in which we store that particular pair. Okay. Now, see one thing. What is this pair? What is a pair? This entire thing, right? We are comparing with only the first and the last element with item 1. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Right. So if I find a match, then what should be done? I'm coming to this part, but first let's see this. First, let's see one of the options. So if I have found a match here with item 1, if I have found a match in either first or last element of another pair, then it is saying option A is saying that if first pair is equal to item 2 or last pair is equal to item 2, then pair count will be equal to 1. So what is this? Why am I checking with item 2 now? It is saying if I find a match of item 1 with first or last element of the next pair, then I am again going to check for item 2 if there is a match in the first or last element of that same pair. And if I find a match again, then only pair count is incremented. So what does that signify? See, again, check the problem statement. It is saying that count pairs should store the list of triples. Wait,
Ma'am, are we checking with each pair?
each pair. So our goal is what? At the end of execution, count pair should store the list of triples such that every triple has 2 items and the number of items in both the number of items and a number of times both the items have been purchased together. So these triplets we want, right? So where are these triplets being formed? Triplets are being formed here. But what is the criteria? So that means this milk bread is one such pair, which we again have to check in every other bill, that whether this milk bread pair exists in any other bill. That means milk and bread are purchased together in any other bill, right? That's why we have to check every single pair with other element pairs. Okay. Like this is one element. This list of lists is one element. This list of lists is another element. So this milk bread is present in both. So can I say that one such triplet should be here like milk bread 2? I can do this because milk bread has been
Yes.
purchased 2 times. That means that much I can say, right? So to get such information, we have to compare all the pairs, right, with every other element pair.
Ma'am,
And
I
at
have one
the end,
question.
yeah,
Ma'am, in the option, and can you show the option once? Ma'am, first and last pair. So, first pair means the first element of the list, and last pair means only the last element of list, right?
yeah.
Ma'am, so how first pair equal to item 2 will be correct? Because item 2 is storing last pair, right? Last of last pair.
Yeah, but that is okay, right? Because these are coming from 2 different cards. Item 2 is coming from the first card, and the current pair that we are dealing with is coming from the
Okay.
second card. The ordering doesn't matter.
Okay, ma'am, understood.
Okay. So item 1 and item 2 are what? First and last elements from the first pair. That is like this. This is one pair. We are taking the first and last element. Milk bread and bread, sugar. Right. Okay. So after we do these comparisons, whatever is the code that has to be filled here, we are not sure yet. But after that is done, see, this if statement closes here, this else statement closes here, and this closing is of this for loop. The while closes here. That means in each while iteration, we are going to form a triple, which is item 1, item 2 pair count. So this pair count is the one that we are trying to find in this fill the code, this part. Okay. That is for every list, we are going to take an item 1 and an item 2, and we are going to find out how many times these 2 items have appeared together, right? So that pair count, once it is calculated, then you can form a triple like this, and then you just add that triple to this count pairs list, which is the original empty list that we had. And then pair list is now equal to rest list. So you remove the first element, that is the first list of lists. The first card information is now removed. So now technically what should be this part, right? So to understand this better, let's go to the solution once and check because they have examples. So let's say this is one card. Okay. SB stores, Akshaya has bought curd, butter, milk. So what are the possible combinations here? Curd, butter,
Buttermilk,
curd, milk,
curd.
and buttermilk.
No, ma'am, there were two.
Anything I'm missing?
No, man.
These are the possible pairs, right? So this is one list of lists. Next,
और बड़का मंदिर
we have, please mute.
बोल
Don't do this. Okay. See. Next, this is another card. So here, a lot of pairings are possible, right? Because there are a lot of elements. So I'm not writing all the pairs here. Now, line 4 in our code, line 4, X pair stores a list of pairs of items purchased in card X. This means X pair stores a list of pairs of items purchased together in card X. If card X is the first card shown above, then X pair should contain these elements, correct? These are the possible combinations for the first card. See, X pairs in our code is this line here. This part of the code, all of you understood that we are just calling the get pairs procedure to get all possible pairs. And then every such list of list element is added in pair list. Right. So that's what is explained here. So X pairs is like this, and then the list of pairs gets appended in pair list. So pair list is another list which contains elements like this. Right. So pair list will be the list of pairs of items seen in the first card. But I have one question. Pair list is a list itself, right? Okay. So X pairs is generating elements like this, list of list, and then these are getting appended to pair list. So it should be a list of list of list. Technically, that's the correct thing, but why they have written just 2 lists? See, they are saying that pair list should look like this. But should it look like this? For the first time, pair list will be the list of pairs of items seen in first card. That is correct. But those are also within a list, right? There should be another list here. That's what the code is saying. That we are appending to a list. So we are appending a list of list to a list. So that means 3 lists in total. Okay, anyways, keep that in mind for now. So they're saying that again for the second card, if we generate X pairs, so these are all possible pairs. Right, again, this will be appended in pair list. So pair list will now become like this. So they're saying that pair list is a list of such elements. There are not 3 lists. Pair list is the list of pairs of items purchased together in the whole data set. But check the code once, is that correct? Pair list itself is a list. If you append to a list, X pairs is a list of list, right? And pair list is a list. So if you append it to the list, then shouldn't it be like that? List of list of list.
No, ma'am, because XPath is not enclosed within a list, ma'am, while appending.
See. Okay, so you're saying that they're just taking the elements and appending them, not the
Yes,
entire.
ma'am.
Okay. So if it was like this,
Uh,
okay, yeah, that's
Yes,
the
ma'am.
mistake.
Then it's a list of list of list.
So that means pair list is just a list of lists, right?
Yes, ma'am.
It is a list of lists. So X pairs is also list of lists. Pair list is also list of list. Now from X pair, we are taking all the elements and appending them to pair list. So pair list at the end of execution of this part of the code, pair list contains what? All possible pairs of elements in the entire shopping bills data set, right? Now the next thing we do is, now count pair is supposed to store the triples. Okay. So to find the same pair, the usual procedure is taken. Only one problem is there, that the order of the items in pairs is not fixed. So that's what I said, that in one pair you might have this banana and banana first, then curd, and another pair might be curd, then bananas. But these are the same pair of elements, right? They're same with respect to the actual items in them. But these two are not same if we compare them like this. So list, as a list, these two are not the same list, right? So we need to check either the first item of the first pair is same as either the first or the second. And again, for the second item, we have to check whether it matches with the first or the second. So see, basically what we are doing is, if I need to compare this with this, I'm checking is bananas present in the first or the last element? Is curd present in either the first or the last element? So if we find match for both, that means this is one pair which has been purchased in another card also. So that is what we are doing in this line 16. See, here, this checking we are doing, right? If first pair is equal to item 1 or last pair is equal to item 1. So this is that same example, that let's say in some list I have milk comma bread, and in some list I have bread comma milk. So my milk is currently item 1, bread is item 2. Okay, and pair is this pair. So I am currently comparing these two. So first pair is bread. First of pair is bread. Is it equal to item 1? Milk? No.
No, ma'am.
Last pair is milk. Is it equal to item 1? Yes. So any of them, if it matches, then we will go into the nested if. So nested if, what should I check? Same for the second element, the bread, right? So the next if should be, again check with both elements if first of pair is equal to item 2 or last of pair is equal to item 2. So here item 2 will match with which one, the first or the last in this pair? First.
First.
So we have found matches for both item 1 and item 2. That means, can I say that these two are identical pairs?
Yes, ma'am.
Right. So can you call them into a triple now? Like, can you increase the number of times that they have appeared together by 1?
Yes.
Right. So that's the part of this code. See. In line 16, the first item of the first pair is being checked. If it is true, then second item should also be checked. If first item is also only not present, then we know that these two are not identical pairs. There is at least one element which is different. Now, if the second item also matches, then pair count is incremented. If it does not match, then pair count, if it does not match, then the pair should be appended to the rest list. That means then you just remove it, go check with the next pair. So after every run, rest list stores the pairs of items which are found to be mismatched with the first pair of pair list. What does this mean? See, let's say in pair list, I have these items. Okay. MB, milk bread, bread milk, bread curd, curd milk, like this. Okay. So I am taking this element first and this element. So by the way, we are checking first item, first and last both with item 1 and first and last both with item 2. So these two will definitely match. So pair count will be increased. Now when I match this one with bread and curd, are these two identical pairs?
No.
So that means bread and curd will go to where? Now
Triple
rest,
list?
rest list. It will come to the else part, no?
Yeah.
See, any of these conditions get violated, right? If the outer if gets violated, you directly move it to rest list. If the inner if gets violated, like this, then also the else part is for the inner if is also you add it to the rest list. So rest list is those elements which are not finding a current match with the first element in the paired list, right? Because we are always working with the first element, matching the first element with all the other elements in the paired list. So those elements which do not find a match fall into rest list. Okay. Why this is so? Because now these are all the unique elements left. So next time I try searching, I will be removing all the milk bread pairs from my pair list so that I don't have to check again, right? So see, now after that, the comparisons are done. After all the comparisons are done, we are out of this for each pair in pair, rest of pair list, this for each block, which ends here. Then we now create the triple. So now pair count is the number of times milk bread pair has appeared in entire pair list. Item 1 is milk, item 2 is bread, and that is the pair count. So now your triple is formed. You add that triple to count pairs. Now pair list is updated to rest list. That means all the elements that did not find a perfect match with milk, bread pair. Now we are going to repeat this same procedure for these elements. Right. So at the end, how many such triples should be there, you think? That is in count pair, how many such triples should be there? As many unique pair elements are there, right? Like milk bread is a unique pair, bread curd is a unique pair. For all of these elements, there should be one entry in count pairs.
Yes, ma'am.
So is according to this, is the first option correct?
Yes, ma'am. It is correct.
Is this MSQ? This is MCQ. So why is the option B not correct? It is checking that first of pair with item 1 and first of pair with item 2. So what is wrong here? Both should be item 2, right? We should check item 2 with first pair also. So this becomes wrong. Again, this one, what is wrong? We are using AND. So obviously, first and last, both if they match with one element, then they are not identical pairs. Right? Either the first should match or the last should match with item 2. The other one should match with item 1. So AND is not the correct statement. In this one also, you're again taking AND and again checking for item 1, which is not required. We are already checking for item 1 in the outer if. This is the inner if. So this is also wrong. Now let's come to the code again. So will it be better if I go through this code one more time? Or has everyone understood?
Yes, ma'am, understood.
Yes, ma'am, understood.
Everyone, right? Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Anyone said repeat?
Yes, ma'am.
See, I'll just quickly tell you what is happening. Okay, so our deal is what? That we have to find that See, in every card, there are multiple elements purchased by a single user, right? So now this get pair, this procedure does what? It takes a card and it generates all possible pair of elements that are possible. If in a card there are 3 elements purchased, milk, bread, and sugar, then what are the possible pairs? Milk, bread, milk, sugar, bread, sugar. So this get pair is to generate these possible pairings. Now, count pairs is the list that we want, which will be a list of triples such that every triple has 2 items and the number of times both items have been purchased together. For example, if milk and bread have been purchased together 3 times, so in 3 different cards, you have found that milk and bread are present, right? Then one triple will look like this: milk, comma, bread, comma, 3. 3 is the number of times these 2 elements have been purchased together. Now we have to form this count pairs triple in such a way that we get each triple like this. So first we do what? In this first while loop, we go through each of the bills in the shopping bills data set. We take each card and we form every possible pairing of the items purchased, right? And every possible pairing is stored in X pairs. So this is a list of lists. Now in pair list, we add every element from X pairs, right? We take every element from X pair and we add it to pair list. So at the end of execution of the first while loop, pair list now contains every possible pairing of element in the entire data set of shopping bills, right? So obviously there are many duplicate pairings also. In multiple lists, milk and bread have been purchased. So milk bread pair will exist multiple number of times. So our job is to find that how many times does each pair occur, right? Now there are certain pairs like this also. Somewhere you might find milk bread and somewhere you might find bread milk. Now these two are exactly identical, but if we talk list wise, then these are not identical lists. So what we do is we take the first element from pair list and we match it with every other element to find how many duplicate occurrences are there. Now these are also the duplicate occurrence. So to check for such occurrences, we take this as item 1, this as item 2. Item 1 is matched with the first and last element of every other pair. Item 2 is also matched with the first and last element of every other pair. So if item 1 and item 2 both find a match with some other pair, that means these two are identical pairs. So only then your count will be incremented by 1. Okay. So that's what's happening here. See, if first of pair is equal to item 1 or last of pair is equal to item 1, that means if item 1, this milk finds a match in any other pair, then we will check for the next item, which is bread. So in this option A, you can see, again we check if first of pair is equal to item 2 or last of pair is equal to item 2. So if now item 1 and item 2 both have found a match in another pair, that means these two are identical pairs. So pair count increases by 1. So at the end, pair count will be storing what? For this milk bread pair, how many times this milk bread pair has appeared throughout the pair list, right? So then once you have that pair count, you can now form the triple. Item 1 is milk, item 2 is bread, and pair count is the number of times these two have appeared together. These two have been purchased together. So that's your count pairs list. Every time you form a triple, you append it to your count pairs, and pair list is now the rest list. Rest list means the entire number, all pairs of elements in pair list except milk bread, right? Milk bread or bread milk. Except this, every other elements are present. So now you again do the same procedure for all the other elements. Is it clear?
Yes, ma'am.
Okay, this is a big question. Usually we don't give such big codes, but yeah, you should go through it once before the exam. Okay, now 6 to 8 is a comprehension type question. So you have to do one code and then answer 3 questions from there. So given pseudocode is executed using scores dataset. At the end of execution, given pseudocode, choose the correct option or options. This is MSQ. So let's see what is happening. Topper is a variable in which we are calling a procedure called find top. Right. What does find top procedure do? It is taking table 1 as its argument. Table 1 is your scores dataset itself, right? So first you take a variable called max and assign it 0, and another variable called top, which is an empty list. Now while table 1 has more rows, so you will now go through all the cards in scores dataset. If the first row, now you read the first row, from table 1, read the first card from scores dataset. And next you check if the total marks in that card is greater than max. Max is initially 0, obviously. So every iteration you are doing a comparison with this max. So if your current total is greater than the current max value, then max is updated to current total and top is updated to this list, x dot sequence number comma max. Okay. So this will continue for every element in your shopping bills data set, scores data set. Okay. Once this is done, then see, move all the rows from table 2 back to table 1 and return top. So what is top? First, let's understand. Let's take a small example. Let's say my first card is of sequence student having sequence number 1, whose total marks is 250. Okay. Second card is sequence number 2, having 270 marks. Third card is sequence number 3, having 190 marks as total. And last card is, let's say, 4 with having 290 marks as total. So this is the first card I read. At this point, first iteration, max is 0, top is empty. Okay. So what is my total? 250. Is it greater than current max?
Yes, ma'am.
Yes. So max will be updated to 250. Top will be updated to sequence number current max, that is 1, 250. Okay. Now you move X to table 2. Go for the next card. Sequence number is 2, total is 270. So 270 is greater than current max? Yes, current max was 250. So you again update max, max becomes 270. Again update top, top becomes 2, 270. Now take the third card, 3, 190. Is 190 greater than current max? 270? No. So no change will happen. Go for the fourth card, 290. 290 is greater than current max? Yes. So max is updated to 290. Top is updated to now. What is the current card sequence number? 4. And what is current max? 290. So after this is done, you move back all the rows from table 2 to table 1 and return top. Okay. So top represents what?
Max. List of max sequence number and the max value.
So there might be 2 people who have scored the high maximum total. In that case, whose sequence number will be stored?
Ma'am, whoever comes first. I mean,
Whoever
earlier
comes
first in
first.
the sequence.
Right. So whoever comes first in the list, right? Because there is no greater than equal to. So it will only take the first topper. Okay. Now you go through the options. So first option is saying topper is a list of 2 elements. So what
True,
is
ma'am.
topper? Topper is just the return value. Top is being stored in topper. It is a list of 2 elements, yes or no?
Yes, ma'am.
Yes. First of topper represents the sequence number of one of the students who have scored the highest total marks. Is this correct?
Yes,
Yes.
Yes, ma'am.
Only one of the students. There might be multiple toppers. C is saying first of topper is the list of sequence number. First of all, it is not a list, right? It is an element. So this is definitely wrong. Last of topper is the highest total mark from table 1. Is this correct?
Yes, ma'am.
Yes, ma'am.
So A, B, and D are all correct. This is clear for everyone?
Yes, ma'am.
Ma'am,
Yes,
this
ma'am.
last topper, can you please explain?
Last topper is what? See, 4, 290. What is 290? This is the total marks, right? This is the highest total scored by any person in the class. Now, this total marks only gets updated when you find a higher total, right? But if this is the highest, it will not get updated. Even if, say, there is some student with sequence number 5 who has also scored 290. So for them also, now this top cannot be updated because total marks is not greater than max. It is equal to max, right? So top is only going to store one sequence number. So the sequence number of the student who has scored the highest total marks, who comes first in the sequence. So last of top is always containing what? The highest total marks in the entire data set. Is it clear?
Got it. Yeah.
Yeah. So A, B, D are the answers. Now part question is, they're saying consider the following procedure, find top, that we just did. Now following pseudocode is executed using scores dataset. Let remove row table Z. So this procedure does what? It deletes the row of table with sequence number Z. So the row with sequence number Z is removed from a particular table if you call this procedure. What will marks list represent at the end of execution? So topper is an empty list, marks list is an empty list. So while table 1 has more rows, this is again the scores dataset only, you're going through that. In topper, you will store find top table 1. So from our example, that was 4,290. So this is the sequence number of the first student we encountered who has scored the highest marks in total dataset. Now remove row table 1 first of topper. That means in scores dataset, this row will be removed where this sequence number 4 students information is stored. Correct. And in marks list, now you're appending what? Topper. So what is marks list? See, we have first found out that this is the topper, 4,290. Then you remove that. Okay. Remove that from the scores dataset itself and then you add it. So obviously marks list currently contains this 4,290. Okay. Now let's say, like I said in the previous example also, some other student has also scored the same marks, 5,290. Then some other student, let's say 17,290, they have all scored the same marks, 290. So once this 4,290, this 4 sequence number gets removed from scores dataset, who becomes the next topper? The next sequence number who has scored the highest marks, that is this 5,290. Right, then they will be added to marks list. Again, they are removed. Next, who is the topper? The next person with the same mark, 17,290. Then they will be added. Again, this will be removed. So like this, we will always keep on finding who is the next topper. Right. So like this, next, let's say all 290 marks are over. So after this, maybe some student has scored, let's say sequence number 3 has scored 280. So this is the next highest marks. Right. Now this will be stored. Again, this one is removed. So like this, it is going in increasing or decreasing order of marks, you tell me.
Decreasing.
Decreasing order of marks, right? So marks list will represent what?
Ma'am,
See,
why
first option,
decreasing?
because you are removing every time you're finding a topper, right? You're removing the row. I found 4,290 as the first topper, but then I removed this information from table 1 using remove row. So now it goes to the next topper, which is this. Again, the next topper, which is this. But at some point, you're bound to run out of these toppers. So now you go to the second highest marks, which is 280. Then again, this will be removed. So go to the next topper, maybe someone who scored 275. Again, next topper, someone who scored 270. Like this, it will go in a decreasing order until you have exhausted all the cards. Right?
Okay, ma'am.
So this will include the lowest marks.
Yeah,
The
this will
marks
include
list.
every marks. Every mark. Marks list. So that is what we are talking about. What is mark list representing? So you see the options. First option is saying it is a list of sequence numbers in ascending order based on the total marks. First of all, is it a list of sequence number?
Yes.
No, ma'am.
But it should be in descending order, not ascending order, right?
But is it a list of sequence numbers?
No, ma'am.
No.
Marks list is taking this
No, it
entire
is
topper.
marks.
So it is the entire pair, right? Sequence, comma, marks. So this one is definitely wrong. This one is definitely wrong because it is not a list of sequence numbers. So you can eliminate first two options. Option C is saying it is a list of pairs of sequence number and total marks in descending order based on total marks. Is this
This
correct?
one is correct, I think.
Yes, ma'am.
Correct. And last one is also saying what is wrong in last one? List of pairs of sequence
Ma'am,
number and
it's in
total marks.
ascending order.
Ascending. So that is not ascending, right? We are starting from the highest. And then we keep on removing the highest total, till we get the next highest, until all the cards are exhausted. So option C is the correct option. Is this clear for everyone?
Yes.
Yes, ma'am, it's clear.
So one more question based on this same code. Question 8. So consider marks list that we just created, right? So what will top list represent at the end of execution? So let's have an arbitrary marks list. Okay, so marks list can look something like this: 4, 290, 5, 290, 17, 290. Just taking an arbitrary list, okay. Let's say 24, 270. So it goes on decreasing like this, okay. So now it is saying that what is top list going to represent? So top list is initially empty, counter is 1, max is containing what? Last of first of marks list. First of all, what is first of marks list? If this is our marks list in question, what is first of marks list? This pairing. What is last of this pairing? The highest total, 290. So currently max is containing 290. Now for each, up to this it is clear, max is 290.
Yes, ma'am.
Yes.
Now for each pair in marks list, so now you go through each of the pairs, each of these elements, and you check if last of pair is not equal to max, right? Then max will be assigned last of pair and counter will be incremented by 1. So how long will we do this? So as long as counter remains less than 4, top list will be appended with first of pair. So let's run this on our list and see what is happening. So max is 290. So for each pair in marks list, what is the first pair? 4, 290. So what is the last of that pair? 290. Is 290 not equal to 290? No. So will I do any of this? No. Again, counter, what is counter currently?
1.
So 1 is less than 4. So top list will be appended with the first of pair. So what is the first of pair? Current pair is 4, 290. What is the first of this pair?
4.
4, 290. So 4 is the first. So top list contains what? It will contain the 4.
Sequence number.
It will contain the 4. Right. Wait. There was one more question. Okay. No, it's fine. So top list will contain this 4. Now go for next iteration. Pick the next pair, 5, 290. Again, the max is equal to 290. So none of this will happen, but counter remains 1. So it will also be appended to top list, 4, 5. Similarly, 17 will also be appended. Now next, when we come to 3, 280. Now is the last of pair equal to 290? No. So max will be shifted to whatever is the current last pair. What is current last of pair?
280.
So max is now 280. Counter is incremented by 1. So counter becomes 2. Now counter 2 is still less than 4. So what will be appended?
3.
3. Let's take a few more elements. Okay. Let's say 18, 250 is another element. 19, 240 is another element. Okay. There are more elements. Okay, so next pair is 24, 270. Again, 270 is not equal to max. So it is again updated. Now max is 270. Counter is again incremented. Now counter is 3. 3 is less than 4. So top list will be again appended with 24. Right. Next pair is 7, 260. Okay. Again, 260 is not equal to max. So max is updated to 260. Last is what? 260, right? 7, 260. So 260 is updated in max. Now counter is again incremented. Counter becomes 4. Is 4 less than 4? No. So will 7 be appended in top list?
No.
No.
So after this, will any of the other sequence numbers be appended in top list?
No.
No, ma'am.
Because counter has already reached 4, right? So what does this represent? What do these sequence numbers represent?
The sequence number of the top 5 students.
No. There might not be 5, right? I might not have 5. I might not have this. Still, there will be 3 sequence numbers and they represent something. What is that?
The top 3 marks of
Top
sprint
3.
sequence.
the sequence numbers of students who have scored the top 3 total marks. Scored among the top 3 total marks. Is that correct?
Yes.
Yes,
So which
ma'am.
option will be correct? List of sequence numbers of students whose total marks is in the top 3 total marks. Is this correct?
Yes, ma'am. The first option is.
First is correct. What are the other wrongs? And let's see why are the others wrong. List of sequence numbers of 3 students. We don't know if it will be 3. In our example, it is 5, right? It doesn't have to be exactly 3. There is no rule that every mark is scored by one singular student. 2 students might have the same marks, right? So this is wrong. C is saying list of pairs of, first of all, there are no pairs. There is only one sequence number. So this is wrong. Second, you also here you can spot the word pairs. Eliminate here only. So A is the correct one. Is this clear for everyone?
Yes, ma'am.
Ma'am, could you explain option B once more?
Yeah, option B is saying list of sequence numbers of 3 students whose total marks is in the top 3 total marks. But it is not that, right? Top 3 total marks can accommodate many students. It can be higher than 3. It can be 3 or greater than 3, right? Let's say
Yes,
top
ma'am.
3
Okay.
total marks is 290, 280, 270. So many students might have scored that. In our case, 290 alone is scored by 3 students. 280 is scored by 1 student, 270 is scored by 1 student. So you cannot say that there will be exactly 3 people. Got it?
Okay, yes, ma'am.
Okay. Next one is number 9. 9 to 11. Again, these are part questions. So given pseudocode is executed using dataset having same fields as words dataset and containing following words. So it is not the words dataset, but it is a similar dataset having same fields. Right. So words dataset, what are the fields in every card in words dataset? What do we find? The sequence number of the card, the word itself, the letter count, the part of speech, these things, right? So now in this new dataset, we have these words present, this paragraph that's given. Now you have to consider this information that unique is a procedure which takes a list as argument and it returns what? A list of unique elements of list L. Right. So you can give it a sentence, it will return the unique words from that sentence. Again, form number L1, L2. So it will take 2 lists and it will give you the number of common elements between L1 and L2. So you can give it 2 sentences or 2 lists, right? 2 lists of words and it will give you how many common words are between them. Again, max A, B, C returns the maximum of A, B or C. Okay, so these 3 things you have to keep in mind. Uppercase and lowercase are ignored when we are checking if a word belongs to positive list or negative list. So it is not case sensitive. What is positive list? So these are the words present in positive list. All positive words: happy, awesome, nice, fine, best, cool. Right. And negative list contains all negative words like dull, worse, ugly, hopeless, bad, these things. Now we have one variable called positive sentence and one variable called negative sentence and one variable called neutral sentence. So all of them are initially set to 0 because till now we haven't checked any sentences to categorize them. And we have a list called L, which is an empty list. So what is the procedure doing? While table 1 has more rows, so now you read every word from this data set, this paragraph, right? So you read the first row, append the word. Then you check whether the word ends with a full stop. If it doesn't end with a full stop, then you don't do any of this, right? Then you simply go and add the next word. But if the word ends with a full stop, so that means, let's take our first example. So I ordered this product from Gitark. So Gitark is the word which is followed by a full stop. So at this point, L list contains what?
List of all the unique words in the sentence.
All the words, not unique. See, we haven't called
Okay.
unique procedure anywhere. We are just reading the word and appending it to L until we
Yeah, yeah.
find a word that has a full stop, right? So all the words in this sentence are currently in list L. Okay. Now, if X word has full stop, so once we reach the word Gitark, it has a full stop. So this condition becomes true. Then what do? You take L and inside in that you store unique of L. So that means now L contains only the unique words from the first sentence. Now, pause count is a variable in which you store the number of common elements between L and positive list. And negative count is again the comparison of, that is the number of common elements between L and negative list. So basically, what is pause count? Number of positive words present in list L, and neck count is number of negative words present in list L. Correct. Where L is unique words from first sentence. Now, if the positive count, so let's do it. So I ordered this product from Github. Okay. Now in this, can you find any such word which is in positive list?
No, ma'am.
No, ma'am.
Any
No.
word which is present in negative list?
No.
No.
No, ma'am.
So will I be incrementing? So what will be pause count and neck count?
0.
Both will be 0, right? There are no common elements. So if pause count is greater than equal to 2 or neck count is greater than equal to 2, then we do all of this. So will I be going into this if loop?
No.
No, ma'am.
No.
We'll
So
go to
the else
neutral.
part,
Yeah.
we'll go to line 20 and we'll say that neutral sentence, this incremented by 1. That means we have found one neutral sentence, right? So this is a neutral sentence. Now once this checking is done for a particular sentence, L list is reinitialized to an empty list so that you can now start storing the words for the next sentence, right? Okay. Now let's go through now that you understand the procedure, let's go through the paragraph itself. Now let's take the next sentence. So now you check how many positive words are there. Happy is a positive word.
2 positive words.
Awesome is a
Awesome
positive
is the
word.
word, yeah. Happy and
That
awesome.
means pause count now becomes 2. What is negative count? Are there any negative words in this sentence?
No.
No. So neck count remains 0. So at this point, come to the line 12. Pause count greater than equal to 2? Yes. Pause count is 2. Right. There is an OR statement. So if any one of these satisfy, we can go inside the if loop. Next, it is asking, is pause count greater than neck count? Yes. Pause is 2, negative is 0. So we can say it is a positive sentence. So positive sentence will be incremented by 1. Okay. Similarly, for all of these sentences, we can find out. Now let's see what the question is asking actually. Based on this information, we have to answer some questions. First is asking, at the end of execution, positive sentences will be what? That means how many positive sentences are there? So we are sure that this is one positive sentence. Now let's check the next one. It is not only nice to use. Nice is a positive word, but also has a very cool look. Cool is a positive word. Are there any negative words in this sentence?
No.
So which count is higher, positive or negative count?
Positive.
Positive.
So this is also a positive sentence. Third sentence, I think this is the best product. Best is a positive word which can be bought in this price range.
But ma'am, there is
But
only one
positive count,
product.
exactly. Positive count is 1 here, right? What is our condition? That positive count has to be greater than equal to 2. So if it is not greater than equal to 2 and negative count is also not greater than equal to 2, then it comes under neutral sentence, right? So far we have found 2 neutral sentences, right? 2 positive sentences. And negative, we have found 0 yet. So this one was a neutral sentence. This one was a positive sentence. This one was a positive sentence. And this one was a neutral sentence. Now next, this sentence, the only bad thing, bad is a negative word, was the broken and ugly packaging. Ugly is a negative word. So here neck count becomes 2, pause count remains 0. So is this a positive or negative sentence?
Negative.
Neck count is greater than equal to 2. So it will be counted as a negative sentence, right? Because it is neck count is greater than positive count. So now we have found one negative sentence as well in the data set. Next, last sentence, so this is negative. I have never seen packaging worse than this before. So how many positive or negative words can we see?
One negative.
Ma'am, one negative.
One negative. So it's
Only one
neutral.
negative. So it's basically a neutral sentence, right? So neutral sentence becomes 3. So there are 2 positives, 3 neutrals, 1 negative. So what is the answer to this? How many positive sentences?
2.
2. Right? So option A. Next question is asking at how many neutral sentences? 3.
3.
Three.
And last one is at the end of execution, the value of comment type will be. So there was one.
Maximum.
So we have to find out the max of positive sense, negative sentences, neutral sentences. So among these 3, the
Neutral.
highest value is neutral, which is 3.
Yeah.
Right. So which one is the answer here? Neutral. A. So 9, 10, 11, all 3 questions are clear for everyone.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This one is an important question for this term. Okay. So keep this in mind. Now last
I
3
have-
questions. Yeah.
Ma'am, I have asked a question in chat box. I have little doubt in it.
Yeah, I will take all the doubts. Okay, let's first finish
Okay,
this
ma'am.
mock, then I'll take the doubts.
Okay, ma'am.
So 12, 13, 14, again based on the same code. So the following pseudocode is executed using Olympics dataset. At the end of execution, medal lists should store the number of players who have won all 3 types of medals and have won at least one type of medal more than one time. That means they must have won gold, silver, bronze, and they must have won at least more than one in any single type. It can be gold, it can be silver or bronze, right? So assume that table 1 always gets restored after every iteration. This is fine. So medal list is that list which should store the number of players, right? So medal list is initially 0. It is called medal lists, but it is a variable. It is not a list, right? So while table 1 has more rows, now we go through the Olympics data set. We read the first card, we check medal lists is equal to medal lists plus qualified medal dictionary, repeat dictionary, sequence number. So basically we are calling this procedure, whatever this returns will be added to current medal list value. So what is qualified procedure doing? It takes a dictionary called medal dict. It takes another dictionary called repeat dict, and it takes n, which is the current sequence number of the card that you have picked. So what does all of this, what does medal dict store? What does repeat dict store? So medals is initially 0, right? Repeated is false. In this medals variable, we are storing length of keys of medal dictionary. So what is that? What is this medal dictionary?
Number of medals.
See, it is clear to us that medal dictionary is a dictionary. That much we can say, right? It is also clear that n is the key of medal dictionary. From this code, you can see that repeat dict, medal dict n. That means n must be key of medal dictionary, correct? That's how we find the key value pairs. So that much we can tell. And the value of medal dict n is again a dictionary, right? Because keys function is being applied. So whatever is the value of this medal dict n is also a dictionary, because on top of that I have applied the keys function. This is clear, right?
Ma'am, could you please repeat?
See, medal dictionary is a dictionary and n is a key of it. That much I can say from the code.
Yeah.
Now, whatever this n key has stored as value, whatever is the value stored against this key n, is also a dictionary, because I have used the keys function on it. Can I say that?
Yes.
So medal dictionary is a nested dictionary, right?
Yeah.
Now, which means medal dict is a nested dictionary. Now, medals is an integer and it is the number of keys stored in medal dictionary n. So medals is basically that only, right? It is the length of keys of this. So it is the number of keys stored in medal dictionary n. Is that correct? Medal dictionary n is a dictionary itself. So the number of keys present in that is what we are storing in medals, correct? Length of keys of medal dictionary n. Now from line 13, as medals is equal to 3, Okay. For now, forget about line 12. Line 13C, if repeated and medals equal to 3. So medals equal to 3 is being checked, and the question was about 3 distinct medals. Then it is evident that the keys of medal dictionary are what? Gold, silver, and bronze. Medal dictionary. I'm not saying medal dictionary N keys. I'm saying what are the keys of medal dictionary? See, again, understand.
Ma'am,
In
could you
line
please
30
take an example?
Yeah, I'll take the example. See,
Ma'am, it should be gold, silver, and bronze type.
yeah. So those are what? Those are keys of medal dictionary N. That means not the key of medal dictionary itself, but the nested dictionary keys. Those are gold, silver, and bronze, right? So that's why the length of medals becomes 3. So if the medal tracking is the first condition, then repeated tracking is the second condition. So basically, look, medal dictionary looks like this. So you have to form the dictionary based on the information from this particular code. So medal dictionary N should be what? What do you think N is?
The name of the player.
For now, let's say it is the name of a player. Okay, so some player name. Against that, what is stored? A dictionary in which I'm keeping track of the medals. So there is a gold medal for which there is a gold key. Let's say this player has won 1 gold medal. He has won, let's say, 2 silver medals, and he has won, let's say, 3 bronze medals. Okay. If this is the case, if a player has won all 3 types of medals, so for them, what should be the length of keys of this? In a dictionary, what should be the
3.
length of keys? 3.
3.
Because they have won
3.
all 3 types of medals, right? So that's what this is saying, that as medals is equal to 3, this is being checked. And the question was about 3 distinct medals. So we want people who have scored at least 1 medal from each category and more than 1 medal in any one category. Right, at least any one category. So then it is evident that the keys of medal dict N are gold, silver, and bronze. So N is, we are saying, some player. Now, if medals is tracking the first condition mentioned in the question. So what is the first condition mentioned? That players who have won all 3 types of medals, that is being tracked by medals. So if medals is equal to 3, that means all 3 types they have won, at least 1 medal from each. Second is have won at least 1 type of medal more than 1 time. So how are we tracking that? So that is being tracked by repeated. See, in line 12, repeated is equal to repeated of dictionary N. Repeated dictionary N, right? So what is this repeat dictionary? So as repeated is a Boolean data type. So can I say if repeated, if it is said like that, if repeated, right? So repeated has to be a Boolean variable, because if this is true, only then I can execute this if statement, correct?
Yes, ma'am.
Medals have to be 3 and repeated has to be true since they are joined by an AND. So I can definitely say repeated itself is a Boolean type of variable which is storing the value that is stored against key N in repeat dictionary. Now as repeat is storing repeat dict N, repeated is storing repeat dict N, right? So value of repeat is decided by this repeat dict N. So as repeat is the tracker of second condition, which is either the player has won at least 1 medal more than 1 time or not. Then medal dictionary is a dictionary with the keys as sequence numbers mapped to true if the player has won the medal. So what does this mean? See, according to our question, repeat dictionary should store what? Just focus on this much. Repeat is the tracker of the second condition, which is that the player has won at least 1 medal more than 1 time or not. So basically, this is wrong. This is not medal dict. This should be repeat dict. So repeat dictionary should be such a dictionary which is like this. So this has some player name N1 mapped to true. When will it be true? When will it be true?
If it get
So,
any medal more than one.
so that is the tracker, right? That we need to find out. So we were talking about player names. In the explanation, it is given as sequence number because names might not be unique, right? So let's say player sequence number we are dealing with. So N is a sequence number. So player sequence number. So this N is also used in repeat dictionary, and that will give true when a player has won a medal more than one time, right? So every time we find such a player who has, let's say, more than one gold medal, more than one silver medal in any category, he has more than one medal, then their entry will be there in the repeat dictionary. So repeat dictionary key value pairs look like this. So N1 is some sequence number of a player. If it is stored as true, if the value is true, that means this person has repeated some medal. If for N2 it is false, that means this person has not won more than one medal in any category. So repeated will only give true when the person has scored more than one medal in a single category, gold, silver, or bronze. So all of this you have to figure out from this code itself. Okay. Is the code clear? So see, now once both the conditions are true, then you return 1. Otherwise, you return 0. And every time you return 1, it goes back to this medal lists and appends. I mean, adds, arithmetic addition. So at the end, medal lists will give you the number of such players who have won medals in 3 categories and have also repeated medals in at least one category. So that is our goal. Is the code itself clear?
Yes, ma'am.
Yes, ma'am.
For everyone, right?
Yes, ma'am.
The question 12 is asking which of the following statements is or are true about medal dictionary based on the above pseudocode. So medal dictionary, they are saying it's a procedure. Is it a procedure? First option.
No.
It's a dictionary.
A dictionary.
So medal dictionary, second one is saying it's a dictionary with sequence number of players mapped to true if the player has won all 3 medals, all 3 types of medals, otherwise mapped to false. Is that true?
No.
See,
No, ma'am.
No, ma'am.
medal dictionary key is sequence number. That is fine. But again, against each key, there is another dictionary stored, which is the gold, silver, and bronze, right? So it is saying that medal dictionary is a nested dictionary with sequence numbers of players mapped to a dictionary with medals as keys mapped to true if the player has won the medal. Is this correct? This can be correct.
Yes, ma'am. This can be correct.
So instead of what we assumed that the count will be stored, they are saying that if I store the true false values instead of the count. So gold true, silver true, bronze true. So can this be a valid option for medal
Yes.
dictionary? This
Yes.
can be valid, but still let's check the last one. Medal dictionary is a dictionary with sequence numbers of players mapped to the list of distinct medals won by the player. Now which one is correct?
C, ma'am.
Why not D?
Because it is not storing the distinct medal, it is also storing the
It is storing
repeated
the
medal.
dictionary, right? It is mapped to a
Yeah.
dictionary. It is not mapped to a list. So here that's the difference. It is mapped to a dictionary. So C is the correct option. You can also check a video solution for this particular question. Okay. This one is clear, right, everyone? See, now tell me, now for a player who has not won a silver medal but has won gold and bronze, for them, what will be the dictionary, nested dictionary? Gold true and bronze true, right?
Yes.
So the length of keys will be 2. That's why they won't be counted. Okay. This is saying which of the following statement or statements is or are correct about repeat dictionary. So repeat dictionary, again, is it a procedure? No. So close it. Repeat dictionary is a dictionary with sequence numbers of players map to the number of medals which the player has won more than one time. Is it
No.
that?
No.
It is mapped to. So next one is saying a number of it is sequence number of players mapped to true if the player has won at least one type of medal more than one time.
Yes.
This is the correct one. And this is how we track whether a medal has been repeated by a player or not. And last one is saying what? It is a dictionary with sequence numbers mapped to true if the player has won at least one type of medal more than one time, otherwise mapped to false. Now which one is true?
C.
So why D is wrong? You're saying?
Because it doesn't assure that the player has got more than one medals in all the three types.
So they are saying that option D is saying that it is a dictionary with sequence numbers of players mapped to true if the player has won at least one type of medal more than one time. So up to this, these two options are similar. The only extra thing is that otherwise mapped to false. So is this not required? If this is not there, then will you be able to track correctly? See, here we are checking the Boolean value, true or false. So which option do you think is correct? Option C or option D? Option D has to be the correct one because obviously for some people it should be mapped to false also, right? Who haven't won more than one medal in a particular category. Do you understand what I'm saying?
Yes, ma'am.
Yes, but my doubt is if it's not mapped to true, then does it not mean that it's
It has to
false?
be mapped to something, right? For
Okay.
every sequence number, it has to be mapped to some Boolean value, true or false.
Okay.
So basically, this also looks correct. But since this is more correct, I mean, I'm not saying this option C is wrong. It is also correct, but this is more accurate since it is covering all the grounds, both for true and false. So option D is better answer.
Excuse me, ma'am.
Hmm.
Had this question been MSQ, then
Always take the better answer. Okay. If there are such ambiguous options, you go for the second one. I mean, whichever one is more accurate.
okay.
Since both of these are similar up to this sentence, right? This otherwise mapped to false is the only extra part.
Yeah, because if the condition was false, then it was exiting the loop, right? It was not going into the loop. So
Then
that
it
is why
cannot, then this condition gets violated entirely, this if statement. It is based on this true value from repeated.
Yeah, I got it. Okay.
Okay. Usually such ambiguity will not be there in your questions. If it is an MCQ, then this type of ambiguity might come. So that is on you, how you will understand which one is more correct. Now last question is, let G, S and B be the list of sequence numbers of the players who have won gold medal, silver medal and bronze medal respectively. So these are lists of sequence numbers of players. Okay. So first you tell me, can there be any intersection between these lists?
Yes, ma'am.
Yes.
Possible, right? Now, if n is the sequence number of a player, then choose the correct implementation of medal dictionary. That is, how will you prepare this medal, create this medal dictionary properly? First one is saying procedure medal dict. N is the argument, sequence number of a player. Initially count is 0. If n is a member of the G list, that is, n has one gold medal, then count will be incremented by 1. If n is a member of S list, has one silver medal, count again gets incremented. If n is also a member of bronze list, count again gets incremented. And it is saying return count. So is this correct?
This one is correct, ma'am. Because it has everything that we need. The count is increasing and the count is initialized to 0.
Okay. So someone is saying this is correct. Let's check the other options also. Second one is doing this. Count is 0 initially, count will increment every time you find that it is a member of G, S or B list. If count is equal to 3, then you return true. So there is a return statement here, and here we were returning the count. So here we are checking if count is 3, then you return true. Otherwise, you return false. Is this the correct implementation?
I think count should be greater than equal to. Wait.
I'm not saying it. I'm just saying, does anyone think this is correct implementation?
What was asked in the question again?
That which one is the correct implementation of middle dictionary, given that GSB are lists of sequence numbers of players who have won gold, silver, and bronze medals. So n is a sequence number of a player. We are choosing how will we incorporate n into middle dictionary, which is the correct implementation for that. So does anyone think option B is correct? Okay, then we'll leave it for now. Now I will ask you one thing. Okay, let's first complete. I'll not say anything now. See the option C. You're forgetting something. That middle dictionary is a dictionary. Okay.
Yeah,
So where
ma'am,
are
this
the key
one,
value pairs? So check this. Here count is 0. Again, we are checking the membership. Does this sequence number is a member of G, S, or B? In that case, increment the count. If count is equal to 3, then for that sequence number, we are storing true. Is this correct implementation?
this looks correct.
Okay, it is also a contender according to you. Let's see the last one. This is saying middle dictionary is empty initially. So here middle dictionary was also initialized. So this much is fine. Next, you're saying table 1 has more rows. Read the first row. Middle dictionary sequence number. For a particular sequence number, we are initializing an nested dictionary. So wasn't middle dictionary a nested dictionary? For
Yes.
every sequence number, we had another dictionary where the gold, silver, and bronze values were stored, whether they were true or false.
Yes.
So isn't this the correct implementation?
This is the correct option.
Option D is correct. Because here you are, see, everything is correct. You have middle dictionary initialized, you have the nested dictionary initialized for every unique sequence number. Then you are checking the membership of gold, silver, bronze medals. This should be B actually, not bronze. And then you are checking the membership, and then you are accordingly writing the key value pairs for gold. If it is a member of gold, then you give true. If it is silver, you give true. If bronze, you give true. So this is the correct implementation. Anyone has doubt in this?
Can you repeat the difference between C and D?
In C, do you see a nested dictionary
No,
for a
ma'am.
particular sequence number? No, right? There is just the middle dictionary. So it is not the correct implementation because we already saw in the first question that middle dictionary has to be a nested dictionary. So by that only you can remove this, eliminate this option. And the first two are blatantly wrong because there is no dictionary involved at all. Right?
Okay.
Is this clear for everyone? Last option.
Yes, ma'am.
So these are all the questions in your mock. Okay, this is the difficulty level you can expect. It will be a little less difficult than this also. But still, if you're able to do the mock properly, it should be easy for you. Quiz 2. Okay. So please go through these questions on your own also once. Now you can ask me any doubt that you might have.
Where can we find this video?
The mock is released to you, right? I think the solution PDF will be updated tomorrow, I think. So tomorrow, I think, is the last date for when is quiz 2? Tomorrow or the day after?
Day after tomorrow.
Yeah, so by tomorrow, I think you'll get the solution PDF. If you don't, then just mail me someone, I will give you the PDF. Okay. All right. Now, anyone has any doubt? Any other doubt from like week 1 to 8? Any topic? Any particular question you can post?
Ma'am, I have posted a question. Can you solve it out?
Yeah.
It's from the one of the PYQs.
This one, right? Anne Thomas?
Yes, ma'am.
Let me download this 1 second. Can you see the screen? Oh, wait, I'm sharing the PDF, right? Wait. Now you can see the screen.
Yes, ma'am.
This is the question. Okay, so what is this saying? Wait, let me zoom in a bit. Floor of n function returns the largest integer value that is smaller than or equal to a number n. Okay, so 1.8 floor is 1 and 2.4 floor is 2. So floor of n is a function that takes some value n, right, which is a decimal value usually, and it will return the largest integer value that is smaller than or equal to the number n, not greater than. Right. So 1.8 cannot be 2. It will always be 1. So that is the basic floor and seal function we know in maths. So remainder x comma j function returns the remainder when x is divided by j. For example, if we take 24 comma 10, then 10 divided by 24, remainder is 4. So it will give you that remainder. Now the code is saying what? You have a list A and an empty list B. For each number in A, you are checking check condition number. So if this returns true, then that number is appended to B list. Now, what is check condition number doing? So it is taking a number, let's say the first number in list A, which is 18, right? It's taking 18. Sum of digits is a variable which is initialized to 0. Temp is containing the current number that you have fed as the argument, so 18. So while temp remains greater than 0, digit is equal to remainder of temp comma 10. So take the example for 18, what should digit contain? What is remainder of 18 comma 10? 8.
8.
Sum of digits is sum of digits plus 8. Right. Currently. See, the entire while loop will iterate. Then temp becomes floor of temp by 10. So 18 by 10. What is the floor? 1.8. What is the floor of that? 1.
1.
So 1 is again greater than 0. Digit remainder. So 1 divided by 10. What is the remainder? 1 itself. So digit now
Yes,
contains 1. Sum of digits is, it was previously 8. Now it is 8 plus 1, 9. And temp is now floor of 1 divided by 10. 1 divided by 10 means 0.1. 0.1 floor is 0. 0.1 floor is 0. So 0 greater than 0? No. So now the while loop stops. So this while loop is execution
Ma'am,
of
so like
sum
we're
of
like
digits.
looping until the temp value is like equal to 0, like
Equal to
less
0.
than 0.
It will always be
Okay.
equal to 0. Okay, it will never be negative because you are doing just simple division operation. Right.
Yes, ma'am. Okay.
So the point here is this is basically the execution of the program where we write a program to find the sum of digits of a number. It is that execution. Okay. So for every number in the A list, you are first going to find the sum of digits. Okay. Now next, line 16, if remainder x comma sum of digits is equal to 0. So current x is 18, right? So 18 comma sum of digits. What was the sum of digits? 9. Does 9 divide 18? Yes. So remainder will be equal to 0. So you will return true. If for some, let's say take the next number in A list, 19. For that, what is the sum of digits?
10.
Does 10 divide 19?
No.
No, ma'am.
That
So
is why
remainder
it is
will not be
exclusive.
0. So it will return false. So every time it returns true, only then you will add the number to B list. Otherwise, no. So now check in this list. Which of the numbers will be divided by their sum of digits perfectly? 18 will be divided by 9. So it will be in B list. 19 is not divided by 10. 24 is divided by 6. Sum of digits is 6. 6 divides 24. So 24 will be in B list. 21. Sum of digits is 3. 3 divides 21 perfectly. So 21 will also be in B list. 13. 13 is definitely not divisible by anything. So it will not be in the list. So B list will contain which numbers? 18, 24, 21.
Okay, ma'am, understood. Thank you.
Ma'am, I have a doubt in graded assignment question number 4.
Which way?
Graded assignment 8.
Okay, let me share it 1 second. Eight, right?
Yes, 8. Question number 4.
Deadline has passed for week 8, correct?
Yes.
Okay. Just check once if this is the question. This one?
Question number 4, yeah.
Okay, what is this saying? Answer. The following pseudocode is executed using shopping bills dataset. At the end of execution, D captures the following information. For each customer Z, D of Z of shop stores the shops visited by Z, and D of Z of category stores the categories of items purchased by this customer Z. But the pseudocode may have mistakes. Okay. So, first of all, what is this D of Z of shop? What do you think the value will be? It is a list, right? List of shops.
Yes. Yes.
And similarly, category is also a list.
Yes.
Now, D is an empty dictionary initially, while pile 1 has more cards. So now you iterate through all the cards. Read the top card. D is equal to update dictionary DX. Okay. So in procedure update dictionary, you take a card and you take the dictionary D. So if the customer name is not a key of that dictionary, that means you have not encountered a card from that customer before. So now you create a key for that customer. That means what are the keys of dictionary D? Customer names, right? Now for each customer name, you have to again assign a nested dictionary in which the keys are what? Shop and category. This is correct. For shop
So,
also you have
ma'am,
a list.
yes. In
Yeah.
this line number 10, the answer is error in line number 10. But I do not find any error in this line. Why the option 10 is correct then? That's what my question is.
Option line 10 is given as this, right?
As the correct answer, yeah.
Okay, let's see once. Yeah, you can use inverted commas, that's fine. And you can also initialize list like this. TY customer name is nested dictionary. This looks fine only.
Yeah, ma'am, because error in line 10 and error in line 14. So error line 14 I understand, but this line 10 I was not getting. So maybe this is incorrect. The line 10 option is incorrect here.
No, I'm looking at line 12 once. So first of all, you initialize that, right? Now, if it is a key, then you don't need to do this. It is already done. Next in you come to line 12. So customer name, shop, and then you have the y dot shop name, which is equal to true. So what is this thing? Y dot shop. Why will you put that and then assign it true? So this shop name basically should be appended to the list, right? To the shop list that is stored against the key shop. Is there any need to put true?
No.
That's my question, because in our question it is not given. We just have to find out that that this DZ shop stores all the shop names and DZ category stores all the category names. So category names again similarly in this line 14 is a clear error, obviously, because this should be category and then you should append all the categories. So I think the errors are in line 12 and 14.
Yes,
line
but
12
that
also listed in option,
it
right?
is listed, but no, it's not listed. Instead, line 10 is listed. I understand there is error in 12 and 14.
Yeah, might be this is a mistake. Let me confirm once with Piyush.
Ma'am, can I say something?
1 second, let me check again. Yeah, you say what you're saying.
Ma'am, since line 12 is not listed, it should be correct. So I
But
think,
see, it is not making sense. That's why I'm saying that how is it
yes,
correct? I
ma'am.
mean, we don't need true value stored anywhere. And
Ma'am,
it is not a key. Y dot shop name is not a key. It is just an element of a list.
yes, ma'am, but shop is not a list, ma'am. It's a dictionary itself.
Shop is a key. Okay. Shop
That
is a
key
key
is,
of the dictionary. And
yes, ma'am.
against that, we are storing a value, which is an empty list. Now, this shop name should be appended to this list. That's what I'm saying. That you append to dy customer name shop, and then you do that plus plus append shop name. Could be that instead of line 10, maybe they have missed line 12, something like that. But I will confirm this once because line 10, I don't see an error. This looks fine to me.
Yes, ma'am. And maybe some students might have gotten the incorrect and their grades will affect, right? Because of this
Right.
wrong option.
Okay,
Yeah.
let me see this once. Okay, I have the solution also. Let's check the solution if they have given any explanation for this. Could be something we are missing. Let's see. So they are saying B and D, 10 and 12. So what is wrong? Error in line 13. Error in line 9. Wait, line 110. So, in line 9, the keys are assigned to empty lists. But that is not line 9, right? That is line 10. Keys are assigned to empty lists is in line 10. I think here the mistake happened. Here they're saying
Yes,
in line
ma'am.
9, the keys are assigned to empty list. This is a mistake in the pseudocode.
Yes.
And empty list, they are saying this is empty dictionary. But the question asked what? That question is saying that captures the following information for each customer Z. DZ shop stores the shops visited by Z. Right. So it is just a simple key value thing. There is no need to have empty dictionaries here and then again have true values. That is not given in the question. I think there is some mistake in this one. Okay, let me discuss with you, sir, once. Then we'll update. If it is wrong, then we'll give marks to everyone. Okay. All right. Yeah. Any other doubts?
Ma'am, I have just shared a photo in chat.
Who is this? This Aman Pandey? This one.
Yes, ma'am.
Okay. Wait, let me share once. This one, right?
Yes, ma'am. I have the doubt. I cannot understand that. How we know that? Then I am confused in
Well, let me see the question once.
starting and ending like the third and fourth option. How we
Let
will
me
know
see
that
once. What
third
will
one is
count
correct or fourth
represent?
one?
What will count represent at the end of execution in the missing code is filled by below code. Is this part of some question?
Yes, ma'am.
What is the full question? If flag and part of speech is not verb, count 1, flag false. X word ends with. I cannot understand from this. Do you have the full question? This is a part question, I think.
No, ma'am. At that time, I do not have the screenshot of that.
Okay, can you tell me what that question was about? Like here, what is your confusion actually?
Ma'am, the question is about it was doing a procedure or pseudocode on a verse data set, and they have given the pseudocode and they have tell us to fill some lines, and then they
Yeah.
give that about this.
Okay, but what was that procedure doing? That is what you have to
Ma'am,
find out. Like, what is count representing?
yes, ma'am.
Okay. So see, from here, what I can understand is if statement, first if statement will execute when flag is true and part of speech is not equal to verb, right? So part of speech is something other than verb. If both these conditions are correct, then count will be incremented. Once count is incremented, then flag again is set to false. And then you check if word ends with a full stop, only then flag will be set to true again. So the only time flag becomes true is when word ends with a full stop, that is at the end of a sentence, correct?
Yes, ma'am.
So now let's say for the next sentence when you go, let's say the first word in that sentence is a verb. Okay, if it is a verb, then flag will be true, but the next part of the sentence, next part of the condition is false, right? Verb not equal to verb, this will violate. So count will not be incremented, flag will be set to false, right? So when
Yes,
will count be incremented? Sentences
ma'am.
which do not start with a verb.
I understand the pseudo code, but I did not understand when the third option will correct and when the fourth option.
Now, see, third option is correct in this case, that when your sentence doesn't start with a verb, because I just told you if it starts with a verb, then at that point only the flag will, this condition will violate, and you will not be incrementing the count, right? You will not be able to increment the count. So count will not be able to show that sentence, and flag will be set to false after that, right? After every
Yes,
first
ma'am.
word iteration, flag is set to false. So only which sentences the count will execute when the sentence is not starting with a verb. Only then the flag will remain true and the X part of speech not equal to verb will be true. Now you are asking when the fourth option will be correct. That is number of sentences which end with a verb.
Yes, ma'am. Yes, ma'am. Like I do not understand when it
So
is
when
talking
this
about
will
the if.
happen is, see, when the sentences end with a verb means what? You have to check the entire sentence until you reach the last word, and then you have to check whether that last word is a verb or not. So in that case, the condition has to change, right? And the flag update also has to change. So here, if you do the flag update after the first iteration, only flag is set to false, then you will never be able to check for the other words in that sentence. So in that case, this entire code will change. First of all, you will check that sentence, can I say, okay, sentence which ends with a verb, right? So you first have to check that the current word you're checking is the last word in a sentence. That you will check with the help of the full stop. If word ends with a full stop, then you check whether current part of speech is a verb. If it is a verb, then you increment your counter and then you set your flag to false or true accordingly. Okay, that will be the code when you're checking for number of sentences which end with a verb. This one is for starting with a verb.
Okay, ma'am.
All right. Anything else? Any other doubts?
Excuse me, ma'am. I have also sent a question. Can you please check in the chats?
Ashmita Malik, this one.
Yes, ma'am.
Can you see the question?
No, ma'am.
Wait. Now?
Yes, ma'am.
So which one? 14 or 15?
And actually, both are linked. 14th is a pseudocode for 15th.
Okay. So following pseudocode is executed using scores dataset. At the end of execution, medal list should have the list of sequence numbers of students who have scored at least 200 total marks and have scored more than 80 marks in at least 2 subjects. Answer the given sub questions. Okay, so medal list is empty, A is 0, S count is false. We'll go through all the cards and check. First, the total marks will be stored in A. S count will be N sub X dot sequence number. So N sub is some procedure, right? You have to understand what this procedure is doing. So what is our condition? That middle list will contain sequence number of those people whose total is greater than 200, greater than equal to 200, and have scored more than 80 marks in at least two subjects. So we can see that in the if statement here in line 6, the A greater than equal to 200 condition is being separately checked and S count has to be true. So when will S count be true? When this N sub procedure returns true for the particular sequence number. So what is the other condition? That this person must have scored more than 80 in at least two subjects. So this condition is being checked by N sub. Okay. So if the person has scored more than 80 in at least two subjects, then S count will, then N sub will return true and S count will be set to true. So if both of these conditions are true, then only the sequence number is being added to middle list. So what can you say about N sub from here? First option is saying N sub is the procedure which accepts the sequence number of a student and returns true if the student has scored more than 80 in at least two subjects, otherwise returns false. So first option is definitely correct.
Yes, ma'am.
Are you understanding why it's correct?
Yes, ma'am, understood.
But it is an MSQ, so check the other ones also. N sub is the procedure which accepts the sequence number of a student and returns number of subjects in which student has scored more than 80. So is this correct? If it returns number of subject, then that is not a Boolean value, right? And S count has to be a Boolean value. So second one is wrong. Again, third is saying N sub is a dictionary. It is definitely not a dictionary. So you can just get rid of last two options because N sub is a procedure. So first option is the only correct one.
Okay, ma'am. Ma'am, could you please explain one more thing, that when, what modification should be done in this pseudocode if we want N sub as a dictionary?
So then what do you want N sub to perform?
Like the same condition only, that
So if
A
N
should
sub
be
is a
greater.
dictionary, then maybe if you want to do the same thing, it won't make much sense. But if N sub is a dictionary, then for every sequence number, it should again contain a nested dictionary where you have the marks stored for every individual subject. So then again, you have to query every individual subject and check if the marks is greater than 80. So basically, you have to write a whole procedure on that dictionary again. So
Okay,
making
ma'am,
N sub as a dictionary will not make much sense. N sub is good as a procedure.
Okay, ma'am, understood.
Okay. Any other question? All right. So if you have any other question throughout tomorrow also, please feel free to mail me. I will try to get back to as many as I can. Okay. Yeah. That's it from my side. Thanks for joining everyone and all the best for your exam. You can leave.